Hello, this is teacher Francis Wamai and welcome to my YouTube channel. In our today's video, we're gonna focus on using dots and crosses to describe electron configuration. In our previous video, we did about electron configuration. If you never viewed it, you can search Francis Wamai YouTube channel, and then you'll be able to see whatever we covered in the previous video. Now here we want to see how we can represent an atom, a given atom, in terms of dots and crosses, such that you can be able to tell what that atom is. For example, we have an atom like hydrogen. Hydrogen has only one atom and one neutron, and that means if you draw a hydrogen, in here we have nucleus, and the nucleus we have neutrons and protons, which are 1 1, and in that case then this one is the nucleus. The very first space, the orbital space here, this is what we call the first energy level, and in that case we only have one electron. So for hydrogen, it can be represented as such. If we have an atom like lithium is in position number 3. That means it has an electron configuration of 2 1, and in that case it means that in here we have protons and neutrons, and we can call it lithium. We don't there is no need of us explaining about neutrons and protons in here. You just take the name of the atom, which is lithium. You write its symbol. Now the first electron configuration, the first energy level, that is, we have 2 electrons, and that means we will have 2 electrons there. And then the one that follows now, this is now the second space. The second space, we said that only the first one carries 2, the others will carry as much as 8. Now we only have 1 remaining, and that means that one can be placed as such, and that is lithium. Now if we have, let's say, a larger one like nitrogen is in position number 7, and that means it has an electron configuration of 2 5. If you try and draw that, you can pause for a moment and try to draw it. We usually start with the inner one. Here we have nitrogen, and with our nitrogen, in the first orbital space, the first electronic energy level, we have 2 electrons. We normally write them as such, and then we have the second energy level. The second energy level is here, which has 5, and that means we will have 1 2 3 4 and then 5. Now you have the first energy level 2, the second energy level has 5. Let's talk of some other element such as aluminium. Aluminium is in position number 13, and that means its electron configuration, you can pause for a moment and try that out, will be 2 8 3. 2 8 3. That means if we draw aluminium, this one is aluminium, the first energy level will be containing 2 electrons, and then the second energy level will be containing 8 1 2 3 4 5 6 7 8. We normally write them in pairs, and the last energy level, that is the third energy level, it is in period 3. If you can remember how we use this method to identify the period, This is period 1, period 2, period 3. That means aluminium is in period 3. Now we have 3 remaining, and that means we can represent them as 1, 2, 3. That is for aluminium. You can pause for a moment and try out for magnesium, which is in position number 12. You can pause for a moment and try that one out. Magnesium, that means the electron configuration will be 2, 8, 2. Now if you do that, we will have magnesium, and then with magnesium we have 1, 2 in the first energy level. In the second energy level we have 1, 2, 3, 4, 5, 6, 7, 8. This 8, and then the last one has 2. The last one has 2. The two of them, you can decide whether to distribute them or write them as pairs, and that means you will put 1, 2. That is magnesium. Maybe you can try a very larger one, say an atom like this one is magnesium. We can try out an atom like potassium. Potassium is in position number 19, and that means its electron configuration is 2, 8, 8, 1. Therefore, for us to know now how to represent it in terms of Dawes and Krauss, we start with the nucleus. This is potassium, and then the first energy level has only 2 electrons. The second one is here, which has 8. And then we have the third one. The third one also has 8. 1, 2, 3, 4, 5, 6, 7, 8. And the last one, which is the fourth energy level, sometimes some other books call it energy band, we have only 1 electron, and for that case potassium is in period 1, 2, 3, 4. 1, 2, 3, 4. That is for potassium. Maybe you can pause for a moment and do this one as an exercise of today, where you can check for chlorine, and chlorine is in position number 17, and then number 2 you can try out for calcium, which is in position number 20. Maybe you can also try out for number 3, a simpler one. Let's say fluorine, and fluorine is in position number 9. Now for this exercise you can draw the energy diagram using dots and crosses. Now this means you can see in our previous examples, if you have decided to use a cross, it is only a cross. Only when a reaction takes place, it is when we can now combine them, and that we shall see when we will be looking at the structure and the bonding of atoms in reaction. Now that is all for today. God bless you. Remember to subscribe, share, and you can also comment. Teacher Francis Omai, thank you.